Okay, so here's the video on superposition theorem. Okay, so superposition theorem is another way to solve AC circuit that consists of two or more independent sources. It also applicable to be implemented for a system that consists of sources that operate in different frequency, which means that superposition is the only theorem or method that can be used if the system given in different frequency. Since the value of the impedance is dependent on the frequency, so the circuit has to be solved in different frequency domain and then convert into the time domain. So the total response is obtained by adding the individual response in time domain. Means that if let's say we have three sources, so we have to consider one source at one time in our calculation by setting other source to 0. Okay. Superposition states that the current through or voltage across an element in a bilateral network is equal to the algebraic sum of current or voltage produced independently by each source. So it means that superposition is the only, as mentioned before, is the only method that we can use for if the frequency are given in different, if the sources are given in different frequency. Okay, so the principle for superpositions is only work on independent source at one time, which all independent sources are set to 0. So if let's say we have voltage source, when we set to 0, it means that, okay, for example, if we set V to 0, okay, so it means that voltage, let's say we have a source here, so if we set V equals to 0, so this one will be short circuit. Okay, so for voltage, if you set to 0, it will react like short circuit, and for current source, when we set to 0, it will react like open circuit. So the dependent source cannot be removed for this case, where we have to they are actually controlled by the circuit variables. Alright, for DC system, superposition is the only method that can be implemented when you have different sources, which is AC in both. Superposition is the only method that can work in AC and DC system. Okay, so if let's say we have a DC source connected to the circuit, so the value of inductance and capacitance needs to be removed as well, since the frequency for this case is equal to 0. So for XL, the value of the value will be 0. The value of X, the reactance value will be 0, and it will act like a short circuit in the DC circuit. Okay, while for capacitor, X will become very large because frequency is 0. So for capacitor in DC circuit, it will act like an open circuit. Okay, let us go through this example. Yeah, the only one example. Okay. Right, for this case, we have a circuit that consists of 3 sources, where we have 2 sources in AC and another one given DC source. And for AC source, we have one given current, and the other one is voltage source. And if you see this, if you look at the frequency for 2 sources are different, where for voltage source the omega is equal to 2, and for current source the omega is equal to 5. So it means that this system is worked in 2 different frequency. So the value for XL and XC will be different for this case. Okay, so let us start doing the calculation. Right, first step, we need to consider one source and remove the rest of the source. So for this case, step 1, maybe we can remain VAC and remove IAC and BDC. Okay, so for voltage source, okay, then the voltage source given in time domain, so convert it into phasor domain. So the answer, so the voltage source, so the phasor domain for voltage VEC is 10 angle 0. Okay, so the omega is equal to 2. And then for current source, when we set current to 0, so this line will be open circuit, and then we have resistor, and then for capacitor we have capacitor, and lastly we have 4 ohm resistor. And for voltage source, if we set to 0, so it will be short circuit here. So we need to find what is V naught at 1 ohm resistor and calculate the value for XL and XC by using J omega L for XL. So J omega is 2 and L is equal to 2, so the answer is J4. Alright, so this is J4, and then for XC, 1 over J omega C. C is 0.1 multiplied with 2. So 1 divided by 0.2 is 5. So negative J sorry, negative J5. So this is negative J5. Okay, so now we need to calculate what is 1 ohm. Voltage drop at 1 ohm. So we can use any method to find V naught here. So you can either look for current flow at this branch in this branch, and then find the V naught by using I multiplied with R, or you can use voltage divider rules. Yeah. But firstly, we need to calculate the parallel impedance here. So Z parallel will be 4 parallel with J5. So negative 5T. So the answer is 2.44 minus J 1.95. Right. And then now the circuit will look like this. So this is J4, and then this is 1, and V naught here, and this is ZP, and voltage is 10. So we can calculate V naught by using VDR. So V naught is equal to we take the value of the impedance itself, divide by the total of impedance. So 1 plus J4 plus with ZP multiply with source. Okay. So plus with 4J plus with 1, so 1 divided by answer multiply with 10. So the answer is 2.5, and the angle is negative 30.78 voltage. Alright, so once we get the answer, we need to convert it into time domain. So this one will be 2.5 cos 2t minus with 30.78 voltage. Okay, so if let's say the frequency given for these two sources are same, so we need to change these two signal in the same function. Means that it's either in cos, both in cos, or in sine, both in sine. Okay, so means that if we this one is given in cos function, so this current source we have to convert to cos function by minus 90 for the angle, on the angle. Okay, so now we already calculate voltage by considering only voltage VAC. Okay, so next step is to remain the IAC and remove VAC and VDC. Okay, so this one is voltage will be short. And then we have current source here, and this resistor and capacitor, and lastly we have 4 ohm here. Okay, so this is 4, this is 1, and we need to calculate voltage at 1 ohm. And the current source given is 2 sine 5t. So it is in instantaneous value, so convert it into transform it into the phasor domain. So we will get 2 angle 0, and the frequency, the omega is equal to 5. So we need to calculate the new angle, the new value for inductive reactance and capacitive reactance. So XL is equal to J, omega is 5, and L is equal to 2. So we get J10. And for XC, 1 over J 5 multiplied with 0.1. So 1 divided by 0.5. So the answer is minus J2. Okay, so this is J10 and this is minus J2. Right, now we can calculate, we need to calculate voltage at V0. Okay, you can use any method that you prefer, like mesh, nodal, or voltage divider, or source transformation. It's up to you, but I think the easiest one is just use CDR, current divider rules. And then once we get current flow at this branch, then we can calculate V0 by using I multiplied with R. Okay, but first step we need to find what is the Z parallel here. So Z parallel is negative J2 parallel with 4. So 4 negative 2J. And the answer is 4.8 minus 1.6. So, right, and then now the circuit has been simplified. And this is set parallel. So this is 1 and this is J10. Okay, so we can calculate current here, IA. So IA by using CDR is equal to the opposite impedance, J10, divided by total impedance, J10 plus weight 1 plus weight ZP, multiplied with the current source. Okay, plus weight 1 plus weight 10J, 10J divided by answer multiplied with 2. So the answer is 2.33 angle 12.09. Okay, and we can calculate V0, V02 by multiply with a current with the resistor. Okay, so since the resistor is 1, so we will get the same value. So this one, sorry, the unit should be voltage. Okay, so lastly convert this into time domain. So the answer is 2.33 sine 5t plus with 12.09 voltage V. Okay. Okay, next calculate VDC. So remain VDC. VDC, remove VEC and IAC. So this one we have inductor, and then this one become open, and we have resistor, capacitor, and lastly resistor and 5 VDC. Okay, so this is 4 and this is 1, and we need to calculate V naught here. Okay, so since this is DC source, so XL and XC value is a dependent frequency component. So for DC system, frequency is equal to 0. So for XL, XL's X will be 0, while for XC it will become infinity. So for this case, XL, so the inductor will be short circuit, while for XC, for capacitor, it will be open circuit. Okay, so we can just remove this and remove the capacitor. Oops. So now this one become short and this one is open. Okay, so basically we the 1 ohm resistor will be in series to 4 ohm with 4 ohm resistor. So we can calculate V naught by using VDR, voltage divider rules. Okay, so V naught. So this one, since the current flow from this direction, so this one will be negative. Okay. So negative 1 over 4 plus 1 multiplied with voltage source, which is 5. So the answer is negative 1 volt. So this is for the third value. And lastly, we need to write down the whole value. So V naught is equal to 2.5 cos 2t minus with negative 30.78 plus with 2.33 sine 5t plus with 12.09 plus with minus 1 volt. Okay, so this is the final answer. So let's say if this omega is the same, so you need to total this two value. Okay, all right. Yeah. Okay, so this is the final answer, which is oh, okay. Okay, let us go through this exercise. Okay. So again, we have three sources. One given in AC, would be AC, IAC, and this one is VDC. Okay, so yeah, for VAC and IAC, the frequency are different. So the question asks us to calculate what is current flow at 1 ohm through 1 ohm resistor. So first step, let us remain. Oops. Thank you. So remain VAC, remove IAC, remove IAC and VDC. Okay, so this one and then inductor. So current will be open, so this one will be open. And then we have 100 ohm resistor here, and we need to find what is V naught here. Okay, so first step, calculate what is the value XL and XC using the omega for omega 2000. So this one convert to phasor domain, 50 angle 0. So XL is equal to J omega 2000 multiplied with 40 milli. So 2000. So the answer is J8. And for XC, 1 over J 2000 multiplied with 20 micro. So 20 micro multiplied with 2000. So this one is negative J25. Right, negative J25, and this one is J8. Alright, so since this 100 ohm and 60 ohm resistor are in series, so basically the current flow in 60 ohm and 100 ohm is the same. Okay, and also voltage drop at this voltage measured at 80 ohm resistor is equal to voltage measured at the total of this resistance, since these two is in parallel. Okay, so first step, calculate the voltage node at this. Okay, so first step, we have to find what is the parallel, Z parallel. So this is 50 angle 0, J8 and negative J25. So ZP is equal to 80 parallel with 60 plus 100, so 160. So this one is so the answer is 53.33 ohm. Lain pula. 80 parallel with 60. 160 lah. Yeah, 53.3. Okay. And then to get voltage here, VA, which is equal to voltage node at this node. So VA, we can simply use VDR. VA is equal to ZP divided by total of impedance ZP plus T8 minus J25 multiply with the source. Okay, 50 volt. So the answer is 8J minus 25J multiply with 50. So the answer is no, so the answer is 47.64 angle 17.78 volt. Okay, so once we get voltage at this node, so it means that voltage measured at total of this resistance is equal to VA. Okay, so calculate I node, we can just use Ohm's law. I node is equal to, so since the direction, the flow, the current that we are looking is the opposite direction, so we have to negative the value. So negative VA divided by 160. So divide by 160. So the answer is negative kan. So the answer is 0.298 angle negative 162.32 ampere. So the final result must be convert to phasor domain, time domain. So instantaneous current I node is equal to 0.298 cos 2000 T minus 162.32 ampere. Okay, so next step, we remain the current source, remain current IAC, remove VAC and VDC. Okay, so the voltage source will be short circuit, and then we have resistor 80 and inductor. So this one is 100 and this is current here. So this is 2 angle 0 and the omega is different, which is 4000. So we need to calculate the new value for our XC and XL. So XC is 1 over J 4000 multiply with 20 micro. So 4000 multiply 20 micro equal. So this one, the answer is negative J 12.5. Still recording. And then XL is equal to J 4000 multiplied with 40 milli. So the answer is J 160. Okay. So this is J 160 and this is J 12.5. Okay. So we need to calculate what is current flow at this branch. Okay. Alright, so for this case we need to so since it involves 3 loops, the easiest way is if we convert to star delta, so we need to use circuit analysis such as nodal or mesh to solve this circuit, because if you use the star delta conversion, it will affect the value of current flow here. So I think it's better to use mesh. If nodal, you have basically 3 equations to calculate, three unknowns to calculate. For mesh, you since it only involves 2 loops, for this loop we already know that current flow here is equal to this value, so we can get only, we need to calculate only 2 unknowns instead of 3 if you're using nodal. So yeah, let us try to use mesh. Okay, so this one is 1, 2, and 3. Right. So for loop 1, since the current source, given the current, we already have current source here, so automatically I1 is equal to this current source, which is equal to 2 angle 0. And for loop 2, apply KVL. Okay, so voltage 1 plus voltage 2 plus voltage 3 is equal to 0. V1 plus V2 plus V3 is equal to 0. So for V1 we have I2 multiplied with the XC, so minus J 12.5 multiplied with I2 plus with, for 80 ohm we have I for 80 ohm is between these 2 loops, so I2 minus with I3, and then for V3 is J 160, and the current is between I2 minus with I1. So I1, just substitute 2 directly in the equation. Okay. So basically, from KVL, we have V1, V2, V3. We have 3 components to calculate, V1, V2, and V3. So V, apply Ohm's law, V equals to I multiplied with Z. So we get this value. And for V2, we Z is equal to ET multiplied with I is between current in loop 2 minus with current in loop 3. Okay, and then for V3, we have J 160 for the impedance multiplied with I is between I2 and I1. So I1 is equal to 2 ohm, so I just simply substitute in this equation. Okay, so rearrange this equation and so for I2, J 12.5 plus 80 and plus J is 160. And for I3, we have negative ET equal to, so this one transfer to the right hand side. So 160 multiplied with 2, so minus will become positive, and then this one is 3 to ohm. Alright, so the answer is 80 plus with J 147.5 I2 minus 80 I3 is equal to J 3 to ohm. Okay, so now we already have current, we already have equation in loop 2. So this one is equation 2. Okay, so lastly for loop 3, okay, again we have 1, 2 and 3. So actually my window suddenly crashed, so I have to redo back this equation. So basically yeah, this is the one that we calculate by considering voltage, and this one we still yeah, so far we already calculate equation 2 for loops 2, and then for loops 3, okay, so we continue up to we continue with loop 3. Okay, so for loop 3 we have V1, V2 and V3 again. V1 plus V2 plus V3 equal to 0. So this is the basic KVL. Okay, so for V1, so 60, substitute the Ohm's law, so 60 for current, the current, since 60 is between loop 3 and loop 1, so I3 minus I1, so I1 is 2, plus with V2, so V2 is 80, multiply with current, so current, since 80 is between two loops, so I3 minus I2, and lastly add with V3 is 100 multiply with I3 equal to 0. So rearrange this. I2 we have only negative 80, and then for I3 we have 60 with 80 and 100. Okay, and for 2, this one so we transfer to right hand side, we will get positive 2 multiplied with 60, which is 120. Okay, so the 80 I2 plus with 240 I3 equal to 120. Okay, so rearrange this in money. No, not again. Oh, not responding. Okay. Oh, tolonglah. Okay, so this one we have rearrange equation 2 and equation 3 in matrix form. So this is for I2 and this is for I3. So I2 we have 80. I2 for equation 2 we have 80 plus j 147.5. And then for I3 for equation 2 we have 80. Okay. And then for I2 for equation 3 we have 80. And I3 for equation 3 is 240. Okay. So multiply with I2 and I3 equal to, so this is the J320 and 120. Okay, so since we need to calculate current I3 here to get I0, so we can just directly calculate I3 and ignore I2. If let's say the question asks you to calculate current here, so then we need to calculate both current. Otherwise, for this case, I0 is equal to negative I3, so just calculate I3. So for determinant 80 plus j 147.5, negative 80, and 240. So this one, A multiply with D minus with B multiply with C. So the answer is 80 plus 147.5 J multiply with 240 minus 80 squared. Okay, so the answer is 12,800 plus with J 35,400 token. And then for determinant I3, substitute this value in value for I3 here in row 2, column 2. Okay, so if you want to calculate I2, so we substitute this value in the first column. Okay, so this one we have J 147.5 minus 80 and J 320 and 120. So calculate the determinant. A multiply with D minus with B multiply with C. So the answer is minus plus 80 -2. So the answer is 9,600 plus with J 43,300. So calculate I3 by dividing determinant I3 with determinant. So the answer is 1.178 angle 7.38. Right? And I note for this case, I note 2 is negative of I3. So negative this value. So we look at 1.178 angle negative 172.62. Right? So write down in time domain 1.178 sine 4000 d minus 172.62. Okay. So next, calculate the value of I naught when we consider VDC, remove VAC and VIAC. Okay. So for the circuit, we have capacitor and resistor and inductor. And for current, this one will be open circuit. Hold on. Okay, so this is 24 volt, 100, and to calculate I naught here. So this is 80 and 60. Alright. Okay, for DC source, the frequency will be 0. So for XC, this one will be open circuit, and this one will be short circuit. So basically, we just ignore this loop. Okay, so we only have one loop here. Right, so basically we calculate current here to get I naught. Can directly calculate I naught. So we can directly calculate I naught by using Ohm's law. V divided by Z total. So since this is in series, since this is series, alright. So I naught is equal to 24 divided by Z total, 100 plus 80 plus 60. So the answer is 4.1. Okay. So write down the whole equation. Right, so this is for the third, and the value for I naught third prime. So I naught equal to highlight we can just highlight this. Tak boleh. Okay. Okay. and then right. So ini pada plus with 1.178 sine 4000 t minus with 172.62 plus with 0.1 ampere. Right. So this is the final answer. So that's all for this topic, subtopic. Okay, bye.